Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be showing you the use of HSM to mill out this deep pocket in this part with these walls that are in a conish shape. If we take a look at this part, we can see that we have this pocket here that has to be milled out. It's actually a pretty deep pocket, and plus the walls themselves are in a conish shape, or actually in a draft angle. We'll start off by choosing the operation of HSM, and we'll start off with the option of contour roughing. Now the tool that I will be using will be a 30mm tool, and if I show you the tool, you'll note that the tool itself is very short at the sticking out of the holder itself. What's important to note when I choose this tool is that we have this other option here called holder clearance. This will keep the holder actually away from the material, not allowing it to crash into the material, but actually moving the tool path away so that we can actually mill this out as deep as possible. If we take a look at our boundaries, we'll be working only within this boundary over here. And in addition, we have our passes. In our passes, we'll put a thickness of 0.3 millimeters, and we'll take a step down of every 10 millimeters as we're going down in the part. Now, if we take a look at our link area, we'll be working climb milling, and in our ramping, I'm going to choose to work with a profile ramping, where my maximum ramp angle will be 5 degrees, and my ramp height offset will be 2 millimeters. Now I'll simply do save and calculate, and then we'll do our simulation. And in the simulation, you'll note I'll be using the option of solid verify, and you'll see that the tool will actually mill out every single area, but you'll also note that the holder is not crashing into the sides, and allowing it to go as deep as possible, stepping out in these areas further out so as to allow the tool to go as deep as it possibly can. Now in my next operation, I'd like to clear out the rest of those areas in a rough cut with a deeper tool, with a tool that's sticking out actually a lot more so it can actually get up close to the end of the walls itself. So I'll start a new operation, again using the HSM, and instead of contour roughing, I'll be using rest roughing. This will allow me to cut only in the areas that need to be cut. And the tool that I will be using in this particular case will be a 16mm end mill. And you'll note that this particular tool is sticking out a lot more from the holder itself. That will allow it to actually go closer to the walls. Again, my constraint boundaries will be the same as it was last time. And in my passes area, we have my thickness. I'll leave that at 0.3, and this time my step down will be every 5 millimeters. It should also be noted that my previous operation is, as you can see over here, the previous operation of the HSM that I've done before. Now in my link area, again we'll be working in climb milling, and my ramping, again I'll choose to work in my profile ramping, and I'll just simply change my ramp angle to 5 degrees. Now I'll do save and calculate, and we'll take a look at our simulation. And as you can see, our simulation shows us what the previous operation did, and in this operation you'll note that the tool will only work in the areas where that has not been machined before, and because my tool is actually longer, it allows it actually to go all the way out as far as we can up into the walls, and including that, it'll also do the pockets at the bottom itself also. What's left to do here, we still have to do the finish cut. Operation, I'm going to choose to work with a cone tool, with a conus tool, on the walls over here. So what I'll do is simply use the operation of HSM, and we'll use the option of constant Z machining. Now the tool, like I said, we'll be using a taper tool, a taper end mill of 20 degrees, and as you can see, that's the tool over there that we'll be using with the proper angle. That's exactly the same as the wall itself. My constraint boundaries, again, I'll be using the exact same constraint boundaries that I used last time. And this time in my passes, since I'm going to my finish cut, I'll leave my thickness at 0. And my step down, because I'm using a conus tool all the way down, a taper tool, I'm going to go down every 10 millimeters. And in my link area, again, I'll be using Klein milling. And one more thing in the passes itself, I only want to go down to this level over here, only going down until the end of this tapered area over here. I'll simply do now save and calculate. And now when I go into my simulation, you'll note, and I'll move this a little slower, my simulation, you'll note that my tool will take one nice pass all the way down as far as we want. That's 10 millimeters. And then when it gets to the next area that it has to go down, it'll work its way down smoothly without actually moving away from the material itself. And this will be completed all the way down until it gets to the very, very bottom of the step that I chose before. And we'll have a very, very smooth finish at the end, and only one retract from the part itself. And as you can see, this is the way the part should be finished, and that's the way the part is finished. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.